Have you ever stopped to think about what happens in that tiny little moment after you hit play on a video or ask your phone for directions? There is this whole hidden world of technology that makes everything just work. So today, let's pull back that curtain and take a look at the invisible backbone of our digital world, distributed systems. And look, this isn't just about the internet on our phones. We're talking about a massive, complex web that connects everything from the device you're holding right now to city-sized data centers on the other side of the planet. It's the infrastructure that powers pretty much every part of modern life. And honestly, it's a real marvel of engineering. But how in the world does it all work so seamlessly? How can billions of people be using all these services at the exact same time without the whole thing just grinding to a halt? Well, that is the big question we're going to tackle right now. So let's start with something we all do every single day. On the surface, using the internet feels simple, right? It's instantaneous. But behind your screen, there's this incredibly complex and fascinating dance of technology making it all happen. I mean, just think about what's happening this very second. You're streaming this right now. At the same time, maybe your neighbor is getting directions, someone across the country is grabbing a file from the cloud, and millions of people are shopping online. How can one system possibly handle that kind of load for billions of us without just completely collapsing? Well, the answer to that massive challenge all comes down to one really powerful idea that is the foundation of the modern internet. So let's get right to it. What is a distributed system? You know, there's this famous kind of witty definition from computer scientist Leslie Lamport that I think is just perfect. It totally captures the weird, interconnected reality of these systems. It's this idea that some random computer you've never even heard of can crash somewhere in the world, and all of a sudden, you can't get your work done. It really drives home how much we rely on this invisible network. Okay, so here's the more textbook definition. The phrases you really want to lock onto here are autonomous computing elements, which just means separate independent computers, and single coherent system. So the whole magic trick is making a whole bunch of different machines act together like they're one giant, super powerful computer. And this is a great way to visualize it. You've got all these individual separate computers, each one doing its own thing. But when you connect them with a network and some really smart software, they all work together. To you, the user, it just looks like one seamless, powerful service. But this idea, as revolutionary as it is, didn't just pop up out of nowhere. Nope. It's the result of decades and decades of innovation. So let's take a quick trip back in time to see how we got from there to here. It really kicked off with ARPANET back in the 70s, just linking up a few machines. Then in the 80s, LANs brought the whole idea into the office. The World Wide Web in '89 connected information on a global scale. But the real game changer? That was 2006, when Amazon Web Services, or AWS, launched the whole cloud computing era, basically letting anyone rent this distributed power. And then, of course, the mobile explosion in 2008 made these powerful systems an absolute must-have. Okay, so we know what they are, we know how we got here, but why go through all this trouble? Why not just build one single gigantic supercomputer to do everything? To really answer that, we gotta talk about a movie. Yep, a movie. Specifically, the challenge of rendering the very first feature-length computer-animated film, Toy Story. This was just a monumental task back in the 90s. How monumental? Well, if Pixar had tried to render all 1,114,000 frames of that movie on just one single powerful computer from that time, it would have taken, get this, 43 years. The movie would literally be coming out, like, right now. So how did they get it done? They built a distributed system. They created something called a render farm by linking up 117 computers. Each machine worked on a small piece of the movie, and by sharing that huge job among all of them, they took a 43-year task and got it done in a tiny fraction of the time. This is the whole idea in a nutshell. Divide and conquer. And that Toy Story example just perfectly highlights the huge advantages here. First, performance. You can tackle enormous problems by breaking them up, just like Pixar did. Then there's reliability. Think about it. If one Netflix server goes down, your movie keeps playing because another one just takes over. A big one is scalability. When it's Black Friday, Amazon can just spin up more computers to handle the rush. And finally, resource sharing, which is as simple as accessing a shared file on Dropbox or a printer down the hall. All right, so this idea of distributing computing power isn't just some cool history lesson. It is actively shaping our future right now. You can actually trace this trend over decades. We started with these huge, centralized mainframe computers. Then that power moved to our desktops. The internet connected all those desktops. Mobile phones put a supercomputer in everyone's pocket. And that brings us to today, which is really the era of computing everywhere, a world with just countless devices all interconnected. And this brings us right to the cutting edge. All those buzzwords you're always hearing about, like the Internet of Things, connecting everyday objects, edge computing, processing data right where it's created, and massive AI models, they're all built on the exact same principles of distributed systems. They all depend on countless devices and servers talking to each other to act like one single intelligent system. So here's the big takeaway. This invisible system we've been talking about, it's becoming more visible every single day. As our cars, our homes, even our coffee makers become powerful, connected computers in one giant, global distributed system, it leaves us with a really exciting question to think about. What will we build next?